Volume problems. When we're dealing with gases, things are a little different. The law of combining volumes, which is related to Avogadro's theory, is that volumes of gases under similar conditions combine in small whole number ratios. The ratio of the volumes is the same as the mole ratio. So if we have this reaction, hydrogen gas reacting with chlorine gas to form hydrogen chloride gas, 1 mole to 1 mole gives 2 moles. The ratio of the volumes is going to be the same. If I have 10 milliliters of this and 10 milliliters of that, I'm going to end up with twice as much, 20 milliliters of that. And here we have it in pictures. 1 balloon of this plus 1 balloon of that, 1 volume, is going to give me 2 volumes of HCl. Hydrogen and oxygen combining to form water. 2 moles of hydrogen react with 1 mole of oxygen to make 2 moles of water. If I have 100 milliliters of hydrogen gas, it will react with 50 milliliters of oxygen gas and form 100 milliliters of water in the gas state. Now, some students are bothered by this because they say, well, how can you take 100 milliliters of something and add 50 and get 100? It's because it's related to the number of particles. If we look at the molecules, we see 2 molecules of hydrogen reacting with 1 molecule of oxygen. And if you imagine those as being little Legos, and you pull these 2 apart, and you pull these apart, and you stick them on the oxygen, and you make 1 water molecule. And you take these guys and pull them apart and stick them on the other one. That, hopefully, is pretty straightforward. We see how that works. How many particles do we end up with? 2. How many particles did we start with? 3. So even though these volumes don't seem to add up, 100 plus 150 does not equal 100. That's not what's happening here, because the hydrogen and the oxygen are recombining to form fewer particles, and so the volume will be smaller. But these ratios, 100 to 50 is the same as the ratio of 2 to 1. Does that make sense? If we take a ratio of 100 to 50, if we divide both sides by 50, we get 2 to 1. The ratios of the volumes are the same as the mole ratios. So that makes volume problems very simple. So in these problems, we have an unknown volume of gas being calculated from a known volume of gas. The path here is different and simpler. It's liters to liters, just one to the other. We only need 1 unit factor. It's the volume ratio. The volume ratio is exactly the same as the mole ratio. Calculate the liters of oxygen gas that react with 49.7 liters of sulfur dioxide gas under the same conditions. I'm going to still use my equation to organize my information. Sulfur dioxide, 49.7 liters, and they want to know liters of oxygen. So my path, I forgot to subscript that 2. 2SO2. That's a subscript. I'm just going to have liters of SO2 directly to liters of O2. So 49.7 liters of sulfur dioxide. I want liters of O2 up here. I'm going to put liters of SO2 down there. Those cancel out. Nobody wants to tell me I screwed up? I screwed up. You see it? I wrote grams. This lame sauce. There, liters. See, I noticed that when I went to cancel it out, because grams of SO2 don't cancel liters of SO2. Okay, now my units are okay. This volume ratio for the gases is the same as the mole ratio. So I look at, there's 2 SO2s to 1 O2. That means I'm going to have 1 liter of O2, 2 liters of SO2. So I get 49.7 divided by 2. My calculator says 24.85. But this starting number had 3 significant figures, so I need to round this and call it 24.9 liters of oxygen gas. Any questions? Sometimes when you have one like this that is actually simpler, it sometimes seems too easy, and then students do all kinds of crazy things to make it more difficult because they think, well, it can't be that simple. Well, this one is. It's just that little bit in the middle, only one unit factor. Let's do another one. Calculate the volumes of hydrogen gas and oxygen gas that react to yield 50 milliliters of chlorine gas, given the following unbalanced equation. Assume that all gases are at the same temperature and pressure. So again, with the balancing of the equations. Here's chlorine. There's 2 of them, and there's only 1 over here. So I can start out by putting a 2 there, get the chlorine straightened out. Now let's look at the hydrogens. There's 2 hydrogens, there's 2 hydrogens, that's good. But oxygen, there's 1 oxygen here and there's 2 there. So that means I have to put a 2 in front of this one to balance out the oxygens. When I change the oxygen, I change the hydrogen. Now I've got 4 hydrogens. So I need to go back over here and fix that. 4 hydrogens. That changes the chlorines. Now I've got 4 chlorines, so I have to go over here and put a 2 in front of the chlorines. Not the only way you could go about balancing the equation, but no matter how you go about it, you should end up with the same result. That was not the easiest way. So there are 2 things being asked here, but I'm only given one number, 50 milliliters of chlorine gas. So there's the chlorine. I'm going to write the 50.00 milliliters. For A, they're asking for volume of hydrogen chloride. So volume, this is in milliliters. It would be simplest to also do milliliters there. So that's question A. And then they're asking about the oxygen for question B. How much volume? Again, milliliters is going to be easier. So let's do A first. The path for A is going to be milliliters of Cl2. This is volume of gases. Just one step. Milliliters of Cl2 to milliliters of HCl. $50 milliliters of Cl2 times milliliters of HCl in the numerator, milliliters of Cl2 in the denominator, just to cancel the units out. The coefficient in front of HCl is 4, so that tells me for every 4 milliliters of HCl, I'm going to get 2 milliliters of chlorine. And this is going to come out to be 100 milliliters of HCl. Any questions about that one? Let's be daring and do this one without writing the path. We're starting with 50 milliliters of Cl2. We're trying to find milliliters of oxygen. it's a one-step thing. So we're going to go from milliliters of Cl2 to milliliters of O2. And the previous unit comes down to the bottom. Again, we're looking to the equation for our ratios here, 1O2 to 2Cl2. 1 to 2. And so here we're going to get 25.00 milliliters of O2. Any questions?